Hey everyone, and welcome to this complete, comprehensive short course on Linux for hackers. If you are serious about stepping into cybersecurity, you have to master your operating system first. Today, we are focusing on Linux essentials. Make sure you grab a coffee, open up your own terminal, and follow along. Let's get started. Our aim is to get a general understanding of the Linux operating system, because we are going to use it a lot in this course. Linux is an indispensable tool and system in the field of cybersecurity. The reality is, many servers run on Linux, and it offers a wide range of possibilities for offensive security practitioners, network defenders, and systems administrators. In this module, we will thoroughly cover the Linux structure, using the shell, navigating the Linux operating system, working with files and directories, basic Linux administration, and permissions management. Before we start typing commands, we need to talk about the Linux philosophy. Linux doesn't behave like Windows or Mac OS, and understanding how it thinks will make you a much better hacker. There are 5 core principles you need to memorize. First, everything is a file. All configuration files for the various services running on the Linux operating system are stored in one or more text files. Second, Linux uses small, single-purpose programs. It offers many different tools that we will work with, which can be combined to work together. Third, the ability to chain programs together to perform complex tasks. The integration and combination of different tools enable us to carry out many large and complex tasks, such as processing or filtering specific data results. Fourth, avoid captive user interfaces. Linux is designed to work mainly with the shell, or terminal, which gives the user greater control over the operating system. Finally, configuration data is stored in a text file. An example of such a file is the etc password file, which stores all users registered on the system. Let's look under the hood at the core components of Linux. The bootloader is a piece of code that runs to guide the booting process to start the operating system. For example, Parrot Linux uses the grub bootloader. The OS kernel is the main component of an operating system. It manages the resources for the system's I/O devices at the hardware level. Daemons are background services. Their purpose is to ensure that key functions such as scheduling, printing, and multimedia are working correctly. These small programs load after we boot or log into the computer. The OS shell, or command line, is the interface between the OS and the user, allowing the user to tell the OS what to do. The most commonly used shells are Bash, Z shell, and Fish. The graphics server provides a graphical subsystem called an X server that allows graphical programs to run. The window manager, also known as a GUI, gives you your desktop environment, like GNOME or KDE. Finally, utilities are applications or programs that perform particular functions for the user or another program. Think of the Linux architecture like a layer cake. At the bottom, you have the hardware, your RAM, hard drive, and CPU. Sitting right on top of that is the kernel, whose function is to virtualize and control those hardware resources. It gives each process its own virtual resources to prevent conflicts. The next layer up is the shell, the command line interface where you enter commands to execute the kernel's functions. And at the very top is the system utility layer, which makes all the operating system's functionality available to you, the user. Now let's talk about how files are organized. This is the file system hierarchy. Everything stems from one single root point at the top and branches downward into specific folders like bin, etc, and home. Let's demystify what these folders actually hold. Here is your directory cheat sheet. You don't need to memorize them all today, but keep these in mind. / is the top-level root file system. Bin contains your essential command binaries, the basic commands you will run. Boot consists of the bootloader and kernel executable. Dev contains device files for hardware attached to the system. etc is incredibly important for hackers. It holds local system configuration files. Home is where each standard user has a subdirectory for personal storage. Lib holds shared library files. Media and MNT are where external devices like USBs are mounted. Opt is for optional files like third-party hacking tools. Root is the specific home directory for the superuser, or root user. sbin contains executables used for system administration. Temp stores temporary files and usually clears when you reboot. User directory contains executables, libraries, and man files. var contains variable data like log files and web application files. On our Kali Linux, we can move to the root directory by typing cd and a /. If we do an ls, we can find the major directories like bin, dev, home, and boot. We can also see that in the GUI. We can click the File Explorer icon at the top. Now, click on File System. And here we can see the folders we discussed earlier. When you open up a terminal, the text on the left is called the prompt. It gives you vital clues. The tilde symbol marks your home directory. A $sign means you are logged in as a normal, unprivileged user. But as soon as we log in as root, meaning we have full administrative control, that character changes to a hash. In our Kali Linux prompt, we can see the tilde symbol, which means we are in the home directory, and the $sign represents we are a normal user. As soon as we use the command sudo su, the $sign changes to a hash, indicating we are now the root user. One of the biggest secrets in IT is that nobody memorizes every command. Knowing how to ask the system for help is a mandatory skill. Let's look at this example. If I want to use a networking tool like curl, but forgot the syntax, I just type curl, -- help, and hit enter. The terminal instantly prints a cheat sheet of all the options I can use. If I want the full, deeply detailed instruction booklet, I type man curl. Now I can read exactly how the tool was built to function. Let's see this in action. To get general help about the wget command, type in wget --help, and we can see the complete syntax and flag details. If we want a complete explanation, we can open its manual by typing in man wget. Here, we have complete explanations of each and every flag. Next, we move to system information. Whenever you compromise a machine or start a new assessment, you need to ask 3 questions. Who am I? Where am I? And what is running on this box? Here are the commands to answer those questions. Who am I displays your current username. ID returns your user's identity and group permissions. Host name prints the name of the current host system. Uname prints basic information about the operating system name and system hardware. PWD returns your present working directory, telling you exactly which folder you are currently sitting inside. For networking, ifconfig and IP show your network interfaces and IP addresses. Netstat shows network status, and SS is used to investigate sockets. Continuing with system information. PS shows the process status, meaning you can see what apps are currently running. Who displays who else is logged into the machine. env prints your environment variables. We also have hardware list commands. ls, blk lists block devices or hard drives. ls, usb lists USB devices. ls of lists open files. And lspci lists PCI devices. Let's put this into practice. I just opened my terminal. First, who am I? It tells me my username. The ID command returns the user's identity, including the specific groups and permissions assigned to that account. Now, let's type pwd. This prints my working directory, confirming I am in my home folder. If I type IPA, I can immediately see my local IP address, which is critical to know before launching any network attacks. To navigate directories without a mouse, we use the cd command, which stands for change directory. You type cd followed by the path, like cd/dev/shm. If you want to take a step backwards into the previous folder, you simply type cd:/ and press enter. Now that you can move around, let's learn how to interact with files and folders. Creating things in Linux is very straightforward. The touch command followed by a file name instantly creates an empty file. The mkdir command, short for make directory, creates a new folder. The move command is a 2-in-1 tool. You use it to move a file from one folder to another. However, you also use move to rename a file. As you can see here, by typing moveinfo.txt /information.txt, we are basically moving the contents into a new name. To actually see the files inside a folder, we use the ls command to list them down. Hackers almost always use the -la flag with it. This lists everything, including hidden files, and gives us crucial data columns. The first column shows the file type and permissions. The second shows hard links. The third shows the owner of the file, and the fourth shows the group owner. The fifth is the size of the file. The sixth is the date and time it was last modified. And the final column is the actual file or directory name. Watch how simple this is. I will make a folder using mkdir command. Let's create an empty text file using touch target data command. Now, if I type ls-la, I get a clean output showing my new file, showing me as the owner, and showing my read and write permissions. It is that fast. Now, if we want to rename this file, we can use the move command. Just provide it the old file name and new file name. And if list down the files again, we can see the file now. When performing penetration testing, you will often need to search massive file systems for passwords, flags, or vulnerable scripts. Finding files quickly is an art form. If you want to know if a specific tool is installed, use the which command. This tool returns the path to the executable file. It allows us to determine if specific programs like QRL, Netcat, Python, or GCC are available on the operating system. For instance, typing, which Python tells us exactly where the Python engine lives. The locate command searches a background database to find files instantly. Just remember to run sudo update db first to make sure that database is up to date. Then, you can search for patterns. The absolute gold standard for searching is the find command. It searches the live file system based on strict rules. Look at this example. Find type f -name *.html outputs files with their respective paths. Let's break down the options. Type f defines that we only want files, not folders. -name indicates the exact name or extension we are looking for. -user root filters files owned by the root user. -size plus 20k filters for files larger than 20 kilobytes. -newer MT filters for files newer than a specific date. And crucially, adding to. Dev null at the end redirects all the standard permission denied errors to a null device, ensuring no errors clutter up your terminal screen. Let's see this in action. I want to find every backup file in my entire system, but I don't want to see error messages for folders I don't have permission to access. I'll type find /type f -name *.back and redirect the error output to dev null. Only clean, readable results are printed to the screen. You will use this syntax heavily in the field. Our final core topic is user management. Cybersecurity often revolves around gaining access to an unprivileged user and then trying to elevate your privileges to become the root user. If you do achieve root privileges, you can read the etc shadow file, which stores user password hashes. To manage these users, we use a few key utilities. Sudo allows you to execute a command as a different user, usually an administrator. su switches your current terminal session to a completely different user ID. User add and user del are used to create or delete accounts. User mod modifies an existing account. Add group and del group manage permission groups. And password allows you to change a user's password. On Linux etc, password file contains user's details and is universally readable, but it does not contain the actual hashes. The actual hashes are stored in etc shadow file. But to read it, we need root rights, so we can use sudo command to read it. And here we can see our Kali user hashes. Okay, you have the fundamentals. Now it is time to get your hands dirty. These lab tasks aim to provide you with practical experience in essential system administration and security skills. Task 1 covers creating and managing users. Task 2 focuses on file management and basic system commands. Task 3 emphasizes using commands to locate files. Through these tasks, you'll gain the hands-on muscle memory that is crucial for managing Linux systems effectively. Here is your mission. Task 1. Create a user with your name, add it to the root user group, and change the current user to your newly created user. Task 2. Create a hidden README file in your user home directory, list down files to clearly indicate the hidden directory, and use commands to list down the current user, system info, and present working directory. Task 3. Show the various commands required to find the files john.list and sudo. Do not skip this step. Open up your Linux environment right now, pause the video, and work through these 3 tasks. The only way to learn Linux is by breaking things and fixing them in the terminal. In this video, we are going to learn to add a new user to Kali Linux, and then escalation it privileges to a root user. We are in Kali Linux. Open a new terminal. Now, we can add a new user in Kali Linux with the add user command. The command will ask to set a new password for the user. Just set a password. If you want, you can provide additional details for the user. And our user will be added. You can verify this by opening the etc password file. Here, you can see that our user is added at the bottom. We can get more details of a user with the ID command. We can see our user is not part of the root group. To add user to the root group, use the command as shown on the screen. Now, we can run the same ID command, and now we can see that our user is now part of the root group. To switch to the newly created user, use the command su-username. Provide the password, and we are now logged in with the newly created user. In this video, we are going to learn to create a hidden file, how to navigate the basic file system, and getting the system and user information. We are in Kali Linux. Open a new terminal. We can use the cd command to change the directory. Use the command cd tilde symbol to change to home directory. The ls command is used to list down the files. Nano editor can be used to create a new file. If you prefix the file name with a dot, the file becomes hidden. You can enter any text in the created hidden file and save the file. Now, if we use ls command, we cannot see the hidden file. But if we use the command ls-la, we can now see the file. Now, let us see how we can get information about the current user and system. The simplest command is whoami, which lists the current user. The command uname-a lists down information about the system, including the kernel version. Similarly, you can check the current directory with pwd command. In this video, we are going to learn to find files in a Linux operating system. We are in Kali Linux terminal. The basic command to find the files in Linux is the find command. The syntax of the command is shown on screen. The command searches all files from root directory to find the specified file. But the command is slow and takes a bit of time to find the required file. There is another command to find the files in a much faster manner. But we first need to tell Kali to update its search indexes with the updatedb command. Next, we can use the locate command to find the files. Now, let us see how we can find the exact location of any executable. We can use the which command to locate the executable location. Similarly, whereas command also provides us information about the executable location. That brings us to the end of our Linux Essentials module. I hope this helped clear up the command line for you. If you got value out of this, hit the like button Subscribe to Cavemen Tech for more cybersecurity training, and I will see you all in the next lecture.